G'day team, welcome back to another video. We've been doing a whole heap of work with our index laws and expanding and factorizing expressions with indices involved, which is a little bit trickier than what we're probably used to, but it's all leading to this big idea of something called exponential equations and functions. So an exponential equation is an equation where the unknown occurs as part of the index or exponent. So something you guys have been exposed to recently. For example, 2 to the power of x equals 8, or 3 to the power of 2x equals 81. So a little strategy we can do, if both sides of the equation have the same base, we can actually equate the exponents. So I got a nifty little example here. So 2 to the power of x equals 8. 8 we know is 2 to the power of 3. So we've got 2 to the power of x equals 2 to the power of 3. The only way this expression or equation can be true is if the exponents are equal. So x must equal 3. All right, we're going to run through a couple of examples together. All right, so this first example, now we're trying to work, so we have, when we're finding x and we want 2 to the power of x by itself. So we're going to divide both sides by 7. Now, 4, we know, is 2 squared, okay? So now that we have our little bit where we're happy, both bases are the same, we can equate the exponent. So x equals 2, all right? So that's the first one. The second one, a little bit trickier, but still quite simple. Divide both sides by 4 equals 3. So that's 3 to the power of 1. Any number by itself is to the power of 1. Both bases the same, so we can equate indices. X plus 2 equals 1. So that means x must equal negative 1. All right. Now this is where it gets a little bit trickier. So first thing I'm spotting, we're trying to find square numbers. So 9 is a square number. So we're going to write that as 3x squared using our little trick from the last video. Minus 12x to the power of x plus 27 equals 0. Now this is beginning to look a lot like a quadratic. All right, we've got a variable squared, take a variable plus a constant equals 0. Okay, we do know a few strategies for dealing with quadratics. So first, check if it's difference of perfect squares. Check if it is perfect squares. In this case, it's not, because 27 isn't a square number. So what we're going to have to fall back on is our sums and products. So 27, we take 27 over here. We need two numbers that multiply to get 27, positive 27, but add together to get negative 12. So let's look at the multiples of 27. So we've got 27 times by 1, and we've got 9 times by 3. I reckon that is looking pretty good, because 9 and 3, we can easily make negative 12 by having negative 9 and negative 3, which still gives me my positive 27. So they're my two numbers. So we've got 3 to the power of x, because it's squared, so we're going to put our brackets 3 to the power of x like that, 0. So my two numbers are negative 9 and negative 3. So just like quadratics, we need to use our null factor law. So 3x take 9 equals 0, and 3x take 3 equals 0. So remember, null factor law, for two things multiplied together to equal 0, one of them has to be equal to 0. So either this is equal to 0 or this is equal to 0. So we can find our x's this way. 3 to the power of x equals 9. Now 9 we know is 3 squared. And voila, we have the same bases, so we equate the indices, so x equals 2. But we also have the same thing on this side. 3x equals 3. Remember, 3 is just 3 to the power of 1, so x equals 1. So there we have it. We have our two solutions, just like that. All right. We're going to leave it there, and I'm going to do exponential functions in the next video. All right.